So I'm here today to introduce our final keynote speaker, Donna Cupkova. Donna is an assistant professor at the Carnegie Mellon School of Architecture, and it should be noted that as of July 1st, she will be associate professor. She received confirmation of tenure promotion this week. Woo. So Donna is also the co-founder and director of EPIPHYTE Lab, which is an architectural design and research collaborative, doing research and design work kind of at the intersection of computational processes, thermodynamics, environmentally driven processes, design space ecology, and experimentation and geometrically driven performance logic. So we're going to see kind of a wide range of work here today, which I'm really excited about. From 2014 to 2018, she was on the ACADIA Board of Directors, so has been involved in that community as well for quite some time. From 2005 to 2012, she was a visiting assistant professor in Cornell University's Department of Architecture, which is where we met. So she was a professor of mine when I was a third-year undergraduate student. So I've been really honored to know her throughout my career. It's just been a big influence on my interests over the years. Donna has work that's been published internationally in professional venues such as Dwell, the Architectural Review, Green Building and Design, Journal of Architecture, as well as many conference proceedings. In May of 2018, EPIPHYTE Lab was recognized as Next Progressive's Design Practice by Architect Magazine, which is published by the AIA. For education, she has a professional degree of engineer architect from the Slovak University of Technology in Bratislava. She completed her thesis at the Academy of Fine Arts in Vienna, and she also has a Master of Architecture from the School of Arts and Architecture at UCLA. So we invited Donna here to give a keynote called Shape Matters, Spatializing Thermodynamics Through Geometry. And as I mentioned, this is a talk that I'm particularly looking forward to just because of the way that she's able to combine architectural design, creative process, creative practice, and all kinds of different inputs from ecological processes that then drive computational process. So I am going to invite her up to give her talk. Thank you very much.
Thank you. Can you hear me? Yeah? Okay, great. Thank you, Chevy. Thanks, Chevy and Tarek, for having me. I really appreciate it. This is my first time at SimAUD. Originally, when I got an invitation, I considered Chevy giving a talk and just me taking all the credit. But then I figured I got to do the work. So this talk kind of trails the trajectory of, I want to talk about a connection between design research practice and pedagogy. So I have actually some undergraduate work there too. I was considering took it out and put it back in about 3 times in the last 2 days. So with simulation being really at the center at the early stage of design thinking, while also acknowledging that this sort of a performative model for architectures has always struggled with the ambivalence between empirical and deterministic approach to information inquiry. And I think this idea of technology is the answer, but what is the question is really critical when we dive deep into some of these models of inquiry, which are very specialized. So as Chevy mentioned, I concurrently with my academic position, I run a kind of a design research platform, EPIPHYTE Lab, that is focused on built environments through the lens of thermodynamic behaviors. And we really kind of design and speculate about architecture that operates like airplanes. Who knows what EPIPHYTE is? Okay, good. So EPIPHYTE is a non-parasitic plan which lives within another plan. So there's kind of a metaphorical context to the name and the way it was established. But it's also a plan which is tightly coupled with a flow of resources, and it kind of connects the resources with the perceptual experiences. So I'm really interested about the kind of explicit or an empirical set of conditions which comes with it, with the design space as we approach it. It's also the work is really centered around the belief that architecture is fundamentally part of a planetary ecosystem, and yet it can be framed within a capacity to perceive experience subjectively. So intention of the work is really to draw a connection between material expression and the later work kind of looking at a sensorial feedback, not in terms of the simulation, but in terms of kind of embedded systems. So my work is really situated within an expanded field of architecture as it relates to ecology and technology. And historically, these territories, and there's a lot of talk on the kind of a disciplinarity and interdisciplinarity and transdisciplinarity. These disciplines were very distinct, and technology was rather a positive as humanist concept, using data-based and industrial method to prevent the ecology from different modes of disruptions. So the ambition is really to kind of design architecture that uses energy and matter to tap into spatial subjectivity, sensorial subjectivity as a part of both aesthetic and ecological experience. Doing so, we do look into kind of research's nature of energy processing of ecosystems to give us some formal cues into organizational logic, and in a kind of a how one deals with the kind of a stable system or systems that need way more resources to maintain and to survive. Part of this is also, and this is the slide I always show to my students in a studio, and I have them vote and I have them choose. This kind of a idea of a environmental ethics is really rooted in kind of how does one deal with ecology as a sort of a main force in terms of the distributing the resources, as well as kind of questioning the notion of capital as we currently have it within what we call a professional practice. So I'm not going to have you vote, but I would be really interested. I don't have an app. In principle, I'm interested in a biological model for architecture as a reactive form, while using computational model, simulation techniques, prototyping as a method for advancing the build work. And so I do operate between practice and academia, so right now Carnegie Mellon EPIPHYTE Lab. And there is sort of structured yet slightly ambivalent allegiance of each project within a set of operative categories. I mean, honestly, I had to come up with this diagram because we do a lot of very different type of work. And I tried to figure out why we're doing different type of work and how it relates to each other. So this is a kind of my organizational chart. And so within a practice, the build and speculative work is structured around scale and a type of engagements with larger contexts, from spaces to environments to landscapes. And we really do kind of go across the scales. And then within academic teaching, pedagogy, and then funded work, the flow is set up more procedurally, from generation of geometry to simulation logics and to building of material prototypes. So all of it is kind of collectively falling into this network diagram of projects which are sort of tangential to each other through formal behavior, but and data metrics, use of code, yet kind of independent on its own in terms of pursuing very specific local design agenda. So I'm just going to kind of run through a couple of these projects and see how far I get with time. And I have to catch a 10 o'clock flight. So spaces are examples of build work focused on specific effect or spatial experience mitigated by geometry. And this is a restaurant recently, last year, completed project in Pittsburgh. The ceiling was inspired by vaulted geometry of ancient Thai architecture while incorporating acoustic and ambient lighting using three-dimensional ellipsoidal vaults. The ceiling supports kind of a sense of individual presence within a small collective space. Ellipsoid is a kind of an idealized version that concentrates the direction of the sound to travel back to the foci point where the table is located. And then the surface of the ellipsoid is materialized through the series of diagonally cut slotted fins that mitigate sound reflections in the space related to high-frequency sounds. So the fins increase the area of elliptical surface to maximize the number of sound reflections. And there's a sort of and holistically, this is a giant diffuser. And essentially the way it works, each bay is very different. The depth varies. And it produces very different sounds. The different frequency of reverberation makes the global diffusion sound more pleasant. So there's a kind of a cutting off the high frequency noise levels to effectively soften the acoustic spatial qualities. And if you in a restaurant, and this is in a kind of a very hard This is hard surface environment, and you can't have a conversation. That was a kind of a, how do you create privacy within a small space? This project was done within like 3 months with the students. The ceiling cost $5,000 total. So there is a kind of a very, the kind of a mode of economy. I call this a barter architecture. I always get kind of called into these barter projects. But it was also part of the students being actually involved in the production of something which was quite exciting. So Waterfall House proposes a new building wrapper as a strategy to ameliorate the hardline contrast between hot and cold, dark and light spaces produced by this modernist round plumb cubicle composition. While it was kind of a south-oriented main room with really radically different sensibilities in terms of how the light and temperature was distributed throughout the space. So while exploring these geometries that would enable sort of a softening effects, as well as sort of immediate weather fluctuation, so this was a kind of a parametric simulation where the sawtooth roof, and we went through sort of a series of exploration, like what is the kind of a most effective way of thinking about the geometry, and using useful daylight illuminance factor to sort of match the roof parameters to the pre-existing structure to also kind of not only minimize the use of geometry by maximizing the surface to solar exposure, but also creating this gradient of experiential light. And so there's always this kind of a quantitative-qualitative relationship that wants to support the kind of architectural intention of how we see things from inside out and outside in. So this didn't get built, but I kind of stole the geometry for another project. This is a project we just finished in New York City. And it actually uses the same geometric principles, but it's a co-lighting. It's a New York City very dark corner space that essentially trying to bring light in, and within there are no skylights, obviously. So a lot of the simulation we use built in the kind of an intuitive way to understanding how we want to design and what are the qualities we're after. So the part of the process is also kind of a building an intuition within away from simulation logic. So environments generally focus on a state of industrial infrastructure, primarily related to water distribution and filtration logic, in the effort to kind of propose the decentralized models that would respond to immediacy of environmental disaster. And as the current condition, I believe, is not that much different from the sort of a 19th century model of a chamber pots being dumped directly onto the street. It's the sort of model of somewhere else. And within a context of urban ecology, for the ecologies, the tall building is no different than a cliff. So this sort of a model of thinking helps us to engage directly with the notion of kind of a biology and non-human creatures within a design space. This is actually a really old project. This was done still at Cornell. And it's a project in collaboration with biomechanical, environmental engineering, I'm sorry. And it's a distributed greywater filtration facade based on William Jewell nutrient film technique that removes pollutant from the greywater through biomass. He's a kind of a father of living machines. He's a predecessor of living machines. So to understand and map the filtration matrix onto the physical space, we use the bitmap to surface translation to manage surface depth. So these are really, really low-level computational techniques to characterize the capacity of water filtration, translating the surface area within a computational bumps to the rate of filtration efficiency, and per volume per panel. And we propose sort of panelized loop system. We built a prototype and kind of projected how the reorganization of the biomass within this kind of form would exist beyond the piece itself. In landscapes, so we're kind of going up in the scale. Landscape, and I'm really interested in landscape within a school of architecture, which is typically very controversial for some reason, position, just because the notion of a landscape really brings in the issue of ecology into the space in a very direct way. And it also shifts away, but the way we approach this within a kind of a issue, structure of the large-scale data, we want to shift away from object of architecture as a primary interest towards engaging the GIS and larger environmental pattern. This particular project is a project that explores land, building, urbanization strategy inspired by sedimentation processes, while using our physical flow simulation tool, EPIPHYTE, that allow for morphological scenarios to be played out in relationship to the surface water flow and terrain absorbency, including building forms. So you actually can input a series of objects, and the buildings are included within a water flow, and it's really kind of targeted towards green infrastructure design. So as the climate change precipitates the loss of habitable ground building and terraforming becomes central to the discipline. So this project kind of couples simulation flow strategy that negotiates sediment deposit and industrial practice of building oil rigs in the ocean. So in order to produce sort of or imagine new forms of habitation, while simultaneously shifting the focus away from the kind of a contextual truth into the constraints of aesthetics and biosynthetic logic. And it goes even further. The goal of these projects, there are kind of a series of them, and I want to show you one, is to really negotiate between a usefulness and creative play to ultimately question the geospatial information, how the geospatial information can affect thinking and probe the sensibilities within an urban behavior, and sort of really look at what do we do when we interpret and validate the data systems. So that was actually evacuation plan in terms of a flat. So this is a piece titled, I forgot. I'm going to call it Contingent Landscapes. It's a physical simulation project that engages patterns of displacement and racial consolidation in Pittsburgh, and that correlate with tech industry expansion and gentrification trends. So CMU is in Pittsburgh. Pittsburgh had pretty intense growth, especially with the kind of a tech culture. And you can look the kind of a consequence of what that means for the city. So what we did, we created a machine object that functions as an interface to slime mold growth apparatus. That it's essentially a plotter with an injection mechanism that feeds the topographical substrate of Pittsburgh and allows feeding the mold spores and precipitates the mold within a terrain, using the data map as a sort of a projection overlay onto the substrate and as a digital guide to feeding pattern. So one can kind of guide the injection feeder, dispense the food, navigate different scenarios of future gentrification growth or urban growth. So it's a kind of it's an object which by itself and the interaction with meant to be somewhat ambiguous. It's tactile, it's gross, it's slime mold, network patterns. They use the path of the least resistance. So in the searching for the food, and really the mapping, the overlay of mapping amplifies the visual interpretive agency, which I think is always critical in what I consider to be as a part of a design school. So this project attempts to both simulate new sensibilities, uncover subjectivity of source information. It spans the gap between sort of digital and material worlds and creating this hypothetical interpretive map of different geopolitical agenda. And sort of the idea that ecology is ultimately a tool to start distinguishing the kind of hierarchies within what does it mean to be ecological within architectural discipline, and perhaps using kind of Bateson as a reference for ecology of mind. I think it's where this project investigating new forms of social consciousness and discourse about urban issues, or meant to, as a sort of a provocation. So in geometries, I'm going to switch to the sort of a pedagogy. So this is a work from undergrad studio, and it really uses the kind of a similar strategy of simulation logic to look at ecology as force, as kind of an extreme force between the landscape, architecture, and architecture, negotiating these representations of urban morphology within ecological processes through drawing and use of simulation, but that kind of hover between the truth and projection. So in the effort to capture the evidence of large-scale terrestrial dynamic, this is actually a motion of an island in Pittsburgh, which was our site, and communicate these large-scale patterns as a form of knowledge and drama that kind of produces an experience and solicits reaction. So this is a three-dimensional simulation where you see the island being moved and sort of the flow pattern within an urban network need to be used while represented, while understanding that the Earth is open to design in a way that, like, when you make a decision about changing something, the pattern changes, behavior changes. And this was in consideration sort of projection of rising waters and extreme weather events, and to propose architectures for these kind of extreme urban environments, typologies of which respond to ecological landscape of perpetual flooding. And in this case, we kind of use architecture as a sort of a precedent transformation transformation of the precedent. So in the studio, the role of simulation is exploited to provide dynamic readings of site ecology, representations of which are directly linked to the physical formation of objects and landscapes. And it's less about kind of a, Timothy Morton would use the word truthiness of information. And it's more about kind of, for students to really develop agility to understand that there is a kind of a systemic reactivity between conditions and intervention of an impact of what their design would have. So the last section, I'll talk more about my research and build work in prototypes. We're prototyping now. And I'm going to talk about issues of surface figuration as a sort of a significant factor in thermodynamics of passive building systems, which occurs primarily due to convection. And the fact that this work is really based on a premise that complex geometries can be used to improve both aesthetic and thermodynamic performance of passive heating and cooling systems, while understanding that there's sort of a capacity of architecture energy is both empirical and perceptive. The focus on kind of a shifting the definition of thermal, there was a lot of discussion about thermal comfort, away from the industry standards towards the capacity of architecture to trigger these perceptions through experience and subjectivity. I mean, and you've guys seen a lot of calculation of the thermal comfort. I mean, basically, you know, for what it means in terms of design of a building, it means that if your metabolic rate is not the rate of a white 40-year-old man, this building is not designed for you. And to me, the kind of a consequence of the formula within a context of what it means, well, who are we designing for, is really radically wrong. And there are a lot of work we're doing on kind of individual sensing, different forms of adaptive thermal model with the students, PhD students, but that's a whole nother conversation. So this work really was started by building a house. This house is now 9 years old. It's sort of served as a proof of concept and jump-started the research into kind of a geometrically actuated thermal mass. This house has no mechanical air conditioning. So it's cooled completely passively through the concrete. When it's outside around over 90, inside is 70. So there's the whole discussion about how do we adapt, what do we willing to live with. But you know, after 3 years, we did post-occupancy usage. So there was enough evidence that this sort of a passive solar principles to create compact and energy efficient dwelling is this is a significant element that played a role in that. The surface area of a thermal mass is maximized to increase the rate of thermal transfer. So the relationship between mass and surface is really critical in terms of its performance. What's really ironic about this house is that this house is LEED Silver certified, and the reason we didn't get higher LEED certification is because we didn't have innovative mechanical air conditioning. And I was like, what? And so the idea of kind of how do we set up standards within a professional practice, how do we kind of think within a logic of matter and the design can be sort of a way of inquire about some of the more scientific principles, to me became really evident. So the hypothesis is that the surface figuration actually plays a role, and the geometry is critical in rate of the thermal, in a kind of how long is the lag, essentially. So we set up a physical experiment in collaboration with our industrial partner, and this process consisted from digital modeling, fabrication. I'm not going to go through everything, but essentially I have about 2 tons of concrete in front of my office of all the tiles that weight exactly the same. And they're in these 5 groups where the surface area is exactly the same. And we use some of the genetic algorithms and sort of a physical testing to essentially say, okay, everything's the same. The only thing is different is how the surface is designed. And you can change completely. We got about 3-hour difference in the re-radiation rate just through the convection. So, you know, we sort of did fairly thorough thermoscanning using kind of a lump capacity method as a way to define individual geometrically driven temperature profiles, and sort of, you know, set up the experiment to prove that this is essentially a way to start thinking about the passive systems in a more design-oriented way. Also, we try to really visualize these conditions within a 3-dimensional field and kind of set up the parallel way of understanding how we can understand it both intuitively and through simulation. We're able to isolate the heat transfer coefficient related to surface geometry then kind of through simulation afterwards to really understand, because I mean, I'm collaborating with mechanical engineering, robotics, material science. So these are all very collaborative projects, but we as architects don't really necessarily run high-level simulations to understand how our design thinking is being affected at that particular moment. So these are has been executed as a proof of concept that that what are the significant factors in terms of the shapes and geometry related to airflow geometry, and how they kind of what are the parameters I can take into my design space into kind of geometric translation, and understand them as a tools within my kind of a intuitive understanding of these systems. So there's a very close relationship between mean geometry and mean curvature. And, is that a thunder? I really don't want to fly tonight. Mean curvature and the airflow. The airflow. So in terms of these phenomena, we started identifying these differences as figures and geometric trends and assigned them potential thermal values. So there's kind of a regression between what are the 4 main geometric conditions that I can understand in relationship to an H function, which is a reverse R value. So this is kind of like how do I give a geometry and R value within a material assembly of a project. And so we can start to understand these 2-dimensionally and 3-dimensionally as well within a start to generate these new set of geometry with the desired thermal lag, if we can kind of build up through this process, build up our library of kind of effective shapes to look at, and this is through machine learning, so to kind of have a new set of tactile or generated geometries which would perform possibly in a way that we want. So at the end, the idea is that kind of design intervention, the way we make or way we design has actually significant effect on environmental dynamics. And the whole idea of this project or this research inquiry is really to look at architecture with radically as a kind of a demechanized environment, going away from mechanized system. And a lot of, and this has been previously discussed as well, we're looking at a overheating planet as well as a lot of cultures that cannot afford air conditioning. And if you can actually manage or offset some of the need for a mechanized system through some of these strategy, I think could be a interesting contribution. So one issue with, so based on this project, there are kind of 3 modes of inquiry and these funded research collaborations I'm currently having. One is on a tool deposition of high-performance building components. So this is essentially the main issue with this way of thinking is that the shapes are climate and size specific. So we're looking at kind of a local specificity in terms of how we're designing these forms, which means that mold making becomes incredibly unsustainable in a way. So this is a project which tries to look at a surface finishing, a kind of combination of deposition and subtraction for the 3B large-scale 3B profile printing. Another thing I want to say is that it's a materiality issue and the fact that concrete is incredibly damaging to greenhouse gases. But what's interesting about that if you think of a changing material properties, the main component which is really problematic within concrete is cement. Cement is about 8% of, contributes about to 8% of our world CO2. And if you think about concrete per unit in comparison with some other materials, concrete is actually much lower embodied energy than a lot of other materials. So, and this comes also from the idea, like, how do we work with our industrial partner? How do we, from academic institution, can start developing these plans of how does industry can contribute to the amount of production that happens? What are the kind of a way of thinking of the production through looking into material itself? And so these are just sort of some of the work where we are at now. So really this particular research agenda suggests direct formal relationship between behavior of airflow and tool path planning for a robotic arm. And this is kind of the quality of the surface we're currently able to print. Trying to see how am I doing on time. All right. So the role of materiality is really critical. And the phenomena of materials in relationship to the weathering and thermoregulation has always been interesting to me. We have done these kind of hacked simulations a long time ago. This is where I come from. There's a lot of concrete. It's kind of stuck with me. And what's interesting about these type of organization is really to kind of inquiry into the microclimate and how through some of the sort of a traditional simulation, one can start understanding within a design space, identifying a certain parameters which we can query directly from the simulation itself. So this was sort of a virtual test bed from which we can access specifically cool data with values in case of incident soil radiation and CFD analysis, but we essentially getting out the geometry. What was kind of important about that is to understand that geometry, both on a kind of an urban ecology scale as much as on a local material scale, really affects how architecture can operate within a biological paradigm. So Moss regime is a prototype for a facade paneling that operates like a tree trunk, kind of a living, breathing, self-regulating system. And the main goal is to really have a self-sustaining biomass. And while using Moss, we have a sort of a mini lab. Our mini lab functions more as a kitchen. For some reason, people I work with like to cook, so we try to cook things into things, and looking at the kind of parameters of the materials from within in terms of the porosity, biological ingredients. How do we use then digital kind of a modeling, and this is actually the same water flow simulation, slightly adjusted for different scale, to understand sort of a localized, because water flow, because when you develop these things, Moss has to establish itself horizontally before you put it vertically. So actually, some of these simulation determine where do we, this is a porous ceramic. So the whole idea was like, how do we help identify the strategic region within a tile where I can start routing materials. Like when I show this to my industrial partner, they go like, we do everything so this doesn't happen, right? And so, and we have this conversation like, how can we integrate some of these strategies into the current material? How can we kind of shift the standards within a industry, especially if we start thinking about the value in terms of from the energy point of view and kind of a thermal add-on value as an energy point of view and thermal regulation for industries actually of a kind of an economical model that is of interest to them. So they're little shifts, but they're happening. Anyway, so this is what we actually wanted to design. So we developed this whole casting method where allowed us to build in different size of pores related to the water capture as a nutrient method. And this is sort of, we did this about 2 years ago, and then I just left it in front of my house. That's how it looks right now. So the last section of this inquiry into a surface is engaging a thermal color as a means of communication with environment and kind of unpacking more design ideas around thermal comfort in buildings. So the focus is really on the kind of reactivity of surfaces as a way of communicating with the environment directly, proposing thermoregulation to operate more as a mood ring. Like you guys, everybody had a mood ring, right? Rather than sort of the optimized engineering system, how can we essentially not design through simulation, but build the materiality, the kind of reactivity directly into the object of architecture. So we overlay previous sort of a passive behavior logic with some active thermal networks with the possibility to kind of create a pathway and embedded connectedness to specific kind of forms of biofeedback while using human physiology and emotiveness as a kind of an actuator to inform design and material expression. While also, I mean, these are a little corny, but the kind of projecting these scenarios of sort of what would human presence in these type of environments be like? How would it change the reactivity or kind of a thermal gradients of reactivity? So this was a first functioning prototype, and we kind of guided by embedded distributed control systems that allowed us to then set up this hierarchy of testing procedures and modeling workflows to simulate the changes in microclimate in response to a human thought. And we're using kind of you guys know the MUSE, the alpha levels, trying to look at a sort of a activation of focus. It's less about productivity and more about kind of a tactility. And to produce sort of more robust piece as a proof of concept, which uses thermochromics and programmable electromechanical controls. to kind of affect surface temperature tactility while using distributed matter and sensory effect, which are rooted in this overlay of kind of a passive, active, and reactive systems. Thank you.
So I'm going to open the floor up to questions, if anybody from the audience has a question, and then I'll run the microphone over to you.
Donna, thank you so much. Really amazing stuff. I guess I have a question that goes back to sort of Billy's talk. Yeah, that's thunder.
Scared.
In the sense of you're clearly working in a multidisciplinary fashion, which is really fantastic, but has it changed how you organize both the pedagogical aspect, the lab, but also the practice? That's sort of part of the question. Like, are you finding different people, or are we still working with mostly architects? And then secondly, this is really fascinating. Mm-hmm. And is this just reactive thermochromic on the surface? And
no, it is this particular one is programmed. We're now in a stage where we have a kind of pathway to, like, I think, I feel it changes. We don't have, so we're in a process of, or we're talking about setting up what we call a Psychosomatic Architectural Lab, with the idea that it is truly an interdisciplinary endeavor. The neuroscientist, who's kind of right now marginally on a team, but we kind of talked about setting up the validation of a system. So there's always sort of a scientific inquiry, but it really comes from what is the larger design question and how do we want to design the environment. So this is an embedded, it's like a heated panel, which thermochromics right now, it's a thermochromic coating, which just shows the variation, right? But it does, the whole idea is that you can scale it up to sort of a radiant heating systems. And like once you start looking at something which is incredibly passive through both combining the thermal lag and, let's say, radiant heat, right? So there's a sort of a bigger picture as to how does this affect architecture, how the geometry can work. And this is very climate specific, right? So I have the idea that we can sort of train the system to learn which geometries would work within which climates. I mean, there's a lot of ambition there. It's very curious and right now exciting. We have series of proofs, just like I showed you. There's partial validations. It needs more. You know, I was just talking to, I forget your name, from NREL, I'm sorry. Yeah, we were shortlisted for the NREL startup for IN2 with some of this work, and just like wasn't quite competitive in terms of the venture capital, right? And so I'm terrible with that stuff. I mean, this is something I'm scared of, the whole startup idea. And so, but it's, in terms of when you go back, like I feel like in terms of how I teach, it did change or evolve the sort of a model of pedagogy, although that really started when Chevy was my first student, right? Like she's this sort of, I had no idea what I was doing, but she got it. I think that the idea was always there, the fact that there is a community like SimAUD and ACADIA, right? That sort of the paradigm of how we make an inquiry has changed and is much more malleable. Our students barely draw by hand, right? Not that it's a good or bad, but that's not a judgment thing. It's that the kind of a familiarity with some of these things, even though they're creative and expressive, it's not like necessarily technically precise in terms of the analysis. I think it's really critical within the pedagogical model. So yes, I have changed that. I got in a lot of trouble for that, but seem to survive. So it's not too bad. But so that change, I think that as this sort of a model, I feel like I'm in a moment of crisis right now, right? That I was kind of fascinated with the whiteboard proposal said about sort of how do you build the business model around this way of working, because that's what we're kind of trying to figure out within academia, how to do that. But I think there is a interest and support. Half the time I don't know what I'm doing, but I think that's kind of part of the drive as well. So I don't know if that's an answer. Yeah.
I'm holding the mic, so I have a lot of power right now. So this reminds me of a conversation I was having with Demetrius earlier about the community of SimAUD, and we were commenting on the fact that we have a lot of papers that are seeking sort of technical truth or trying to follow a process to answer a performative question with a lot of rigor. And we tend to attract a lot of people that are kind of crossover from the engineering field, that are sort of, I think as Billy mentioned, maybe already directly related, or we have a history of working with architects. There's already some shared kind of energies there. But that we're maybe not doing a great job of bringing in sort of more simulation as a creative process, which is something that I see in this work as being really kind of tantalizing. Like, I can imagine 100 things I want to do with this process.
Right.
And the fact that you're not trying to optimize something, but you're sort of exploring through a process is intriguing to me.
So there are two things, right? One is the kind of a pedagogy of this, and I teach this way, and I teach with simulation as a creative process, and it's embedded in a studio, and and we do the solar analysis, and they do the kind of they know per kilowatt hour per square meter. It's like, but it doesn't become a sort of a value judgment on the quality of the project at the end necessarily. But on the other hand, in terms of the kind of collaborations, when we started doing these tests, and this was actually in Ithaca, and you might know David Bosworth, who sort of built a testing booth behind his house, and we sort of set up the daylight sighting, and these first thermal maps were essentially generated in like all of our labs, right? And it's like, it does work, like we know it works, we just need a proof. And then I had to have that in a way, and there's this kind of an intuition, the house work. There is the rule of thumb works, but there is more to the rule of thumb. And when you think about a rule of thumb of like passive systems like thermal mass, it's incredibly unexciting, right? And I have a lot of stories about that particular project. I was also 8 months pregnant and driving U-Haul with a lot of foam because they shut our 3D CNC mill at Cornell at the time. But it's when I started working with Professor Yao, who is the fluid dynamic expert. What's interesting about some of these kind of scientific, the pre-computational, he's an emeritus, pre-computational scientific inquiries that he was looking for a phenomena, right? It was like, look at this, we can trace the phenomena. If you can describe the phenomena and design within a phenomena, that's how we can then set up the simulation, because I was like looking at these things like, I think this is how it works, but I'm not an expert. And so I think there is a sort of a, this why in terms of working with, let's say, chemists or material scientists or biologists, the kind of model of inquiry within science also differs, right? So if you work with ecologists, the empirical, it's similar what Billy was saying, right? That sort of what you see and you understand is part of the kind of a way to overlay against how do you build your model. So we always build our models based on kind of design idea in a way. So it's a totally reverse. Like, I don't know what a solution is, or I maybe have a sense of what a solution is. And then you kind of inform your intuition with some degree of scientific inquiry. So it's a feedback loop in my mind, yeah.
Are there any other questions from the audience? So I don't just keep asking them from the front row.
Yeah, thanks for the fantastic talk. I'm just wondering about the concrete that you said they work really hard to have that not happen.
Oh, okay, so I showed you about like 10 projects with like footnotes, right? Because I like to kind of show, this is my like whole architecture proposal, but there's a lot of deep dive into each of these projects. So The company I started working with is a high-strength concrete company to do rain screen, like a very patterned rain screen, and it's all about kind of quality of finish. Like they're super interested in this sort of a way of, because we can now sort of say, okay, if you take this geometry, it has this thermal rating, right? Like what's the R value of a geometry on some of the stuff you already have? And that was their kind of a surplus business model of like, oh, like, and their geometry really does very little, honestly, but you know, they were interested in that. And it sort of took this longer conversation for them to understand, okay, you can start thinking about, a lot of it is about the weathering, how things weather. And a lot of environmental testing within the industry goes with the warranty and liability and yada, 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 right? So there's the whole nother framework. However, if you start saying like, okay, there's a way to control the weathering, and there's a way to have another surplus value which has to do with CO2 consumption or kind of a larger environmental effect. There's a way to kind of combine that thinking even within an industry. But generally, if you look at the kind of engineering approach to the facade design, it's like, I don't want anything growing on anything, right? And so to say like, no, it's actually, we can engineer it, and then it can, you know.
I was thinking of that in addition to controlling the finishing, but then also controlling where you have some interesting weathering through growth, together with the new process of embedding CO2 into concrete as a potential food source for some living things.
Yeah, I mean, I think this is to me, this is a territory. There's some CO2 sequestering proposals going on already. I mean, it's a sort of an emerging, very, very slow emerging, but I think like CO2 sequestering within a concrete industry, it's like we can save the planet, right? And and how hard is it to understand? So why can we shift our environmental ethics to other priorities so we can actually incentivize that model within an industry, right? So I mean, it's a difficult proposition within this climate right now, but there are solutions, and they come from a design solution. There's a lot of research which is already kind of haven't proven that we can radically cut down CO2 within our discipline. So why not? However, the whole concrete thing really started from, I mean, I grew up in communism, as you know, and what, why is that funny? No, I mean, I showed the image. I always try to get away from concrete. And utopia.
You're doing a bad job.
No, but so those images I showed with the panelized housing, the things growing. So what happened after the fall of communism? So you know, during the communism, we had district heating. We had very low footprint. We had collective ownership of everything. I got kicked out from my biology class because I claimed that pen is mine and it's my private property, and it was inappropriate comment. So, but after the revolution, essentially everything got privatized. So everybody got kind of a fake thermostat on their wall, which became this sort of ornamental aspect of like, well, this doesn't really work like that, but like here is your another utopia of this sort of individualized ideal. And what happened that all the kind of a hallways landscape, which before was collectively taken care of, nobody took care of it. And what was interesting is the ecology took over. And so some of the parts of the city actually, people started to, it was very bottom up, where there started to be parks. And there's like, the buildings started falling apart, right? I mean, but I like that. But my point is, there's a whole notion of kind of how does one think about organization, organizing sort of, what are the kind of latent patterns within a local site, and how the ecology actually, if you enable those patterns locally, how it can sort of communicate with the built environment. And so that was also the kind of a phenomena which initiated some of these things. Like, it's already happening. Like, what we're doing, we're preventing it. If we allow it, and if we allow it intelligently, we might have something better. So that's where this is coming from.
Thank you. It was fantastic. Question on this idea of performative aesthetics, right? I mean, quick introduction. I spent maybe like 2 months trying to develop like a facade pattern for a partner at Foster & Partners at some point, which was based on a wrong solar radiation analysis. So it should have been just like one color, and it was just a gradient. Are we maybe obsessed with organic forms, and could it be that, you know, a flat panel is more performative? And what would that, I don't know, I'm just trying to investigate the conflict.
So I've been reading Being Ecological by Timothy Morton lately, and there's this one fascinating concept he describes as a sort of a form of knowledge, and it's called attunement, right? And then he talks about the sort of the way we know things is through empathy and connectedness. Like, things are connectedness, and then the kind of appearance of things and the substance of things cannot be peeled apart, right? It is what it is. It's a bad facade, and it looks like that. It's a good facade, it looks like that. And you might think it's a good facade, and somebody else might think it's a bad facade. So the kind of a role of subjectivity in terms of how we set up these heuristic models of what if we think of a value and a knowledge, to me is really interesting, because, and this is what I meant by kind of moving away from a performative model, which you've seen I use in very sort of, when I kind of know my very limited range of performance I'm familiar with or I'm kind of comfortable with. But there's always kind of a questioning of things. I don't think that the, I think that I came into this with a particular idea of a design agenda. So what I'm showing doesn't necessarily come from the kind of emulating natural forms. It's really interesting to me with some of the airflow dynamics, like what I'm getting, what we're starting to get in terms of how much lag things produce. So it's less about like things have to be organic or I want it to be organic, and more about how does one kind of choreographs these gradients of spaces which are sort of the kind of a low energy, right? Like, what's the shape of low energy in a way? And you could see the apartment which is finished. I mean, it's very almost like modernist aesthetic, and it has to do really just kind of a basic light reflectivity. And so a lot of kind of the way we define a problem leads to the kind of a formal language, and I'm just saying that we should be aware of that. I'm not necessarily saying it should look organic. This is just...
Well, and to add on that, we see a lot of people that start an optimization process, but still from a set of inputs. And oftentimes those inputs are like boxes or rectangles.
Yeah.
I think it was Dennis that showed, like these are the buildings that we use as a baseline, or Freed said that, yeah. So if we take that as like we're inputting certain forms, in a way those are sort of arbitrary to begin with, but then we compare everything to those forms.
But I think we still live within kind of a modernist ideology of efficiency, right? And industrial mechanization and industrial logic of how we produce materials. Like, I walked into, yesterday when I walked in the afternoon, and I don't know whose paper it was, I just walked in the last slide, and the conclusion of whatever they were doing was like, architecture should be more diverse and should be better designed. And I'm like, yeah, I mean, that's, but what, but, and it's sometimes we do go through these kind of a modes of inquiries, which are in a way like phenomenally kind of obvious, right? And how we define efficiencies or effectiveness within the design space, to me, it really has to go more with kind of a phenomena of what are the qualities we're looking for, and we can fit the model to it. I mean, I work this way, but I feel like I more like hacked the simulation to in a very sort of, probably a lot of you would disagree how we do things, but from kind of a scientific point of view and what our values are. But we do talk about it, and we do engage this method, and they're kind of, we do try to validate the models, but models are not given.
I usually ask questions, but in this case, I'm going to make a comment back to your comment, Angelos, which what I read in your work is a real fascination, but also an implicit hypothesis about the, let's just say the role of surface features or microfeatures or localized features versus globalized features. And from the plant in the wall, where we know that that's a localized feature that allows for the smallest amount of material to allow something to grow. You know, I see the same thing in your surface features. So I think there's a process here where, which is really interesting in all the work from all the scales, where you're able to talk about these localized features versus globalized features and the real role of those localized features and discover what they do. So there's this real question, I think, that comes up in your work perhaps about the role of scale and the role of feature, both locally and globally. And what comes to the fore from that. Yeah. And you can discuss, and clearly your characterization regimes allow you to discover, right, as much as top-down say what they are, right, also allow you to discover what they are.
It's absolutely true, and what's fascinating to me that scale matters, and those features perform very differently. It is essentially, I'm doing the same thing with the facades than with the landscape, I mean, admittedly so. But they do very different things, and in a way, it's just kind of that's the form of kind of abstraction where I'm saying, like, okay, you know, it makes a difference, and you can see what kind of difference it makes, and you can evaluate it, and you can put a metrics onto it if you dig deeper. But that is significant, and I think that what we do as designers is exactly that, right? We design these features, so having kind of and this is what I'm trying to say, and I don't know quite how because I haven't formulated it yet. How do we sort of think of design education within a context of impact on the world and ecology? To me is really important. And it's this very different model than the model of kind of a professionalism that is now kind of prevalent, especially in the BARC and MARC curriculum. And I was just saying that earlier yesterday. I think we just ran an ACSA conference in CMU, and Wang Shu of an amateur architecture studio had a keynote. He's the Pritzker Prize winner. Do you know his work? Who knows his work? Their work. Okay. So and it was my kind of like, okay, I can now talk about, because I always felt like I'm not the professional, I'm the amateur who wants to change the professional framework because it doesn't make sense to me sometimes, not always, but, and so hearing somebody say essentially the same thing, saying like, look, in China we have these buildings in a city and they don't make any sense, and professional architects build that, and like, so I'm not a professional architect because I don't build that way. I'm an amateur architect. And there was incredibly kind of inspiring and heartwarming to see that level of engagement of that kind of work, to sort of start thinking within much more of a local and how it impacts the community. Obviously, you can translate it in embodied energy, in a carbon footprint. Like these things are, the phenomena of quality are always, we can always develop an inquiry into how we evaluate it metrically. But if the metrics takes over the quality, that's where the problem becomes really huge. That's why I always say, you know, Cedric Price said it, like, technology is the answer, but what is the question? And I think that's a really important question not to forget when we develop professional practice.
So I think we got to move on to the closing comments. So I just want to have everybody thank you, Donna, for your talk.
Thank you for having me.